Okay, everyone, we will be doing the milestone 3 today, and as usual, I will prepare my environment. So this is using the Azure uh, subscription from the Learn on Demand. Okay, portal azure.com. Yeah, okay, so typo. Okay, yep. So as usual, we log on first using the given username. Okay. Yep. So then we also will be logging in our beloved website, tiny URL. Yep. Okay, before we do anything else, we need to create the Azure Machine Learning Workspace first. That's the most important because time is ticking. Okay, so Machine Learning Workspace. Yep, okay. So we're going to create a new one. Okay, so today is a milestone 3 RG and MLW milestone 3. Okay, so the rest use the default setting. We have done this many times. Click create. Okay, while creating this machine learning workspace, we prepare the environment. We go to this website. Then after that, log on to the milestone folder. Then download this one, the dataset. Okay, downloading and done. Yeah. So we go to folder, then extract everything from the zip file. Extract all. Okay. So here you go. We will be using this student performance dataset. Okay, we minimize first and can close. Okay, so the guideline is here, clustering for student performance. Yeah. I have opened in my other screen, so I will be using that for guiding me. Okay, yes. Here you go. Yeah, so milestone 3. Okay, let's have a look here. Still in progress. So in summary, what we will be doing, the first is to create the Azure Machine Learning Workspace. Then as usual, we create a compute instance and then upload the dataset, then create a pipeline. Then we're going to configure the clustering. Yeah, okay, so close this one. Go to the resource. So you take the screenshot as needed because you will be using this for your final project report. Yeah, so normally you collect more screenshot to prepare for the better report. Okay, so launch the studio. Okay, after that quickly create the compute instance. We have done this many times, yeah. So no need to read the instruction. Okay, so wait until the text box appear. Okay, so Ryan CM com instant, yeah, compute instant CPU, then choose the cheapest one. Okay, so for the rest just use the default setting. Okay, so creating now, leave it, yeah, go to the data. So we're going to create a new data set, yeah. Okay, data set name is the student performance. Okay, so just copy the same. Okay, type is tabular. Next, you from the local file, then you're going to upload, yeah. Okay, upload file folder, upload the file. It is from the download folder. Here you go, student performance, open. Okay, wait for a while. Okay, click next, then just quick preview, nothing wrong. Then we just keep the UTF-8, then comma as delimited, yeah. Then click next, after that next, and create. Okay, so in progress. Wait for a while until the data set is created, yeah. Okay, refresh. Okay, so looks like okay now. So go to the data, then this one is created, yeah. Okay, then go to the designer. We're going to create the pipeline. Okay, so close, then create a new pipeline. Okay, in the pipeline we're going to rename to the student name performance, student performance, yeah. Okay, so yep, student performance clustering. Okay, click next, save. Okay, so we drag the data, student performance. After that, we're going to build the pipeline. So the first, create a new pipeline. After that, rename the pipeline, add the data set, and then add the data transformation module, which is first is clean. Yeah, clean missing data. Go to the component, clean missing data. Okay, so after that, in the clean missing data, we're going to clean all the column. So we just use everything, follow the lab instruction, yeah. All column, then remove the entire column. Okay, so save, after that close. Okay, after that continue with the normalize the data. in the normalized data, we're going to set the column, our study, and so on. So I'm going to copy. Okay, so use the C-score, and then after that edit the column here. So in the column name, I'm going to use the clipboard type text. Okay, yeah, click OK. Yeah, enter. Okay, check if there is any type of mistake, but looks like okay. Yep. After that, edit the metadata. Meta. In the edit metadata, in the column, we're going to change to the this. Type from the clipboard. Okay. Yeah, so all the column looks like okay. Save it there. Okay, and then in the data type, we don't change categorical, we change to categorical. And then field unchanged, new column name, no, yeah, nothing. So save it, then close. Now we convert the indicator value from the edit metadata. Yeah, indicator. Okay, so copy the column name. Okay, then override yes. Okay, then after that ready, we're going to split the data. So I will reduce the zoom 75%. Okay, so get the split data. Okay, so split to 70-30, and then random is true, and then stratified column is true based on the learning disability true. Okay, learning disabilities true. Okay, learning underscore disability is true. Save it. Yeah, save. After that close. Then we track the k-mean clustering. Okay, then after that train the cluster. So in the k-mean clustering, you're going to configure to follow the single parameter, then a tree centroid, Then k-means initialization, random speed noting, matrix Euclidean. Yeah, after that the normalizations is through iteration 100 times, and then the ignore the label column. Okay, save it. Yeah. Okay, after that we connect this the untrained model to here, and then the trained dataset here. After that we add the assigned data to cluster. Okay, so the result dataset okay, so we scroll down. Okay, so the trained cluster model, the output of the trained model is you give here, you link, and then the from the split data testing, we give the data, the testing data to here. Okay, then after that continue with the evaluate model. Okay, link. In the train cluster model, we configure the column dataset, select all column, and then yep, save it. Yeah. Select all column, then after that connect the k-means clustering model and split the data output. Okay. Yep. Okay. Good. Okay. Let me check again the. Yeah, looks like everything's okay. So now we're going to save, and then after that we're going to run the pipeline. So configure, after that create a new, the name of the experience ML underscore projects, then the display name is Milestone3. Okay, then click next. In the output nothing changed, so this one using compute instance, just now we already created. Okay, then next, after that submit. Okay, so we use the exactly the detailed instructions. After that we're going to see how this executed. Go to the jobs. Okay, so we have this milestone 3 is still running. Okay, yeah, so we're going to see how the data is being grouped into the 3 cluster. Okay, okay, let's see the progress. Yeah, still doing the cleaning missing data. Okay, yeah, so I think I make a mistake, yeah, in the edit metadata. Failed, yeah, so let's see here. Okay, teacher quality not found, yeah. Okay, column with a name or index teacher quality not found. Okay, so let's have a look. What is the column name? Okay, preview the data. Okay, teacher. So what is this? Teacher quality. Yeah, so we have this teacher quality. Teachers underscore quality. Okay, let's see what happened. Clean missing data. Okay, normalize the data. Edit metadata. So strange. Yeah. Let's go to the designer. Edit metadata. Edit the column. Okay, teacher quality. So very strange. Okay, one moment, let me check. Yeah, everyone, I think I know I make a mistake just now when I check the clean missing data. Yeah, so this should be remove entire row, not entire column. Yeah, so that's when the column value is got the missing, then the column entirely deleted. Yeah, okay, so that's my mistake. Okay, so I corrected the mistake, then after that close. Yeah, then I need to rerun again. So configure submit, use the existing. Okay, then yeah, milestone 3 just override. Yeah, okay, review submit. Okay, yeah, preparing to submit. Okay, so we go back to the jobs. Careful, yeah, I just now I made the mistake. Okay, so go back to the jobs. Okay, ML project. Okay, yeah, this one you can delete. Yeah. Delete, then yes, you can leave it or delete, doesn't matter. Okay, so now it's running. This time this should be okay. Yep, okay. Clean missing data. Just know the reason why it's taking long because it's removing the column. Yeah? So I should not remove the column but remove the row. Okay, this time is faster. So after cleaning the missing data, initially remember you have the 16,000, 14,000 row. Yeah. Okay. The data set size is 14,000. We have open in Excel, but after cleaning, then we get less because as David mentions last week, there are two last column that after the 6,000 rows plus, then both rows are empty, so the rows are deleted. Okay, this first experiment I follow exactly the instruction as per in the milestone guide, but later when we have time we try to play around, then keep the data more by excluding the last two columns, then we will see the difference. Yeah, okay. Yeah, so splitting the data. Wait for a while. Okay, so the splitting data done, and now is training the cluster model. Just wait for a while. Okay, now the training finished, then assigning data to cluster, and in a while more we will see the result. Okay, so almost done evaluating the model. Maybe we zoom out a bit. Then the mouse is a hang. Okay, yep, okay. So zoom out a bit. Okay, everyone, done already. Then we evaluate the model. Preview the data. Okay, so there are 3 clusters created, and then after that, from the 6,000 data, the 3% is about 1,800. Yeah. 6,000. Yep. So 30,000. Let's see. Combination. Yeah. So correct. Yeah. So about let's see the inner designer. When we split the data. Oh, 0.5. Yeah. Correct. Yeah. Is that correct? Let's see the splitting the data. Oh, okay, I make a mistake again. Okay guys, so this should be a 70%. Yeah, okay, save it. Yeah, okay, sorry, let's do it again. Review, submit, then after that close, submit. Okay, just no small mistake. We instead of 70%, I keep default 50%. Okay, but this won't be repeating the clean missing data. Okay, let's go to this. Yep, so this is the latest one. Yep, so only repeat on the split data, because this we didn't change, so it used the information from the cache. Yeah, split data finished. Then now continue with the training the cluster model. Okay, the training completed. Now we continue with the assign data to cluster. After that, we will see the evaluate the model. Okay, done. Yeah, so this time we can preview the data. Yeah, 30% of the 6,000 is around the 1,900. Yeah, okay, correct. Yeah, and how to interpret this data is when you perform the clustering. Yeah, basically the machine learning will group the data into the number of the cluster which we assigned earlier, which is 3. Yeah, so it will create the cluster 0, 1, 2, and then after that it will choose the center, the centroid of the cluster, and then keep moving, yeah, until the every observation, every data, every row assigned to the cluster with the minimum distance. So in this example here, for the cluster number 0, there are 578, and average distance to the cluster center is 2.5. Yeah. This is 2.4, 2.4. Then overall is 2.4 or 2.5, close to 2.5. Yeah. And then if you look at this, yeah, the number is quite okay, almost balanced, except for the cluster 2 is slightly bigger. And how the assignment we can see from this assign data to cluster when you preview. Okay, one moment here. Let me just close this. Okay. Preview data, result dataset. Okay, this is the, for example, the row number 1. Then after that, this is the assignment. Yeah, assigned to the cluster 0, cluster 2, yeah, cluster 1. And then this is the distance from the center of the cluster. This is abstract, because we don't know how the center of the cluster is decided. It's basically through the iteration to find the optimal location where every point will have the minimum distance. So like distance to the cluster center 0, 2.3, yeah, 2.9, 2.6, yeah, for the cluster 1 and 2. So it will choose the minimum, yeah. So that's why this assigned to the cluster 0. This one, the minimum is 2.4, so assigned to cluster 2. Normally, you would like to check whether this model clustering is reliable, yeah, for helping to group the data. Like last time we have the penguin, yeah, based on the body size, yeah, and a few other informations. There are 3 species, yeah. Then we can check, yeah, whether the machine learning model can discover the formula algorithm, yeah, to group the penguin into the correct species by the body measurement. Yeah. Okay. But here, for example, we have the student performance that we don't know which data is suitable for grouping the student into 3 clusters. So we just use a k-mean clustering and let the machine learning to decide for us, yeah, to choose the right model. So the usage is if there is any student new one, yeah, then after that you want to categorize, then you can pump that data, ingest the data into the model, then model will give you the cluster assignment. Yeah, this should go to the cluster 0, 1 or 2. Okay, we still have time, 16 minutes plus the extension later. So we would like to play around, like David mentioned, there are 2 columns, the last 2 columns that uh, 8,000 row are empty. So we would like to try to compare if we keep that data, but we exclude the column. Yeah. Okay. So here I'm going to create a similar experiment, but before that I have to exclude the last 2 column. Yeah, the last 2 column. Select column in the dataset. Okay, so I put here. And then the data is same in just from here, but let's see the name of the last 2 column. Okay, the name is study physical interaction and study extracurricular. Okay, study physical interaction and extracurricular. So here in the edit select column, I edit column, yeah. Then choose the all column, then exclude column name, yeah. Then study physical interaction, and then study okay, okay, this one extracurricular. Yep, save it. Okay, the rest are the same, so I'm going to just copy from this. Yeah, so how to copy? I minimize a bit the zoom out. Okay, so until we split the data, so here we hold the control button to select multiple. Okay, after that control C, then to copy, control V to paste. Yeah, okay, so we have the parallel similar. Yeah, we link this data set into this. Okay, I move this a bit to link, then return back. Okay, yeah, then the rest is continue the same, and then we're going to add this k-mean clustering as well. This, after that this and this. So we copy. Okay, yeah. So let's arrange a little bit higher. So the k-mean clustering is put here side by side, and then after that train cluster model. Okay, after that assign data to cluster. Okay, then after that evaluate the model. Okay, so for the split the result data set I'm going to put here. Yep, then the testing is here, and the result data set is here to compare side by side. Okay, looks like nice like this. Yeah, side by side. Okay, anything else? Don't think so. Okay, good. Yeah, so we only exclude the two column, yeah, through this, so the remaining are the same. Okay, then we're going to compare. Save it, then run. Okay, so select existing ML project. Okay, so we put the compare. Yeah, compare student problem cluster. Next. Okay, so use the same compute instance, then submit. Okay, so we create the two experiment from the same data, and then after that train, then the result are compared in the here. Evaluate the model. Look for the which one is better. Okay, let's go to the jobs. Yeah, compare student performance. Running. Yep, so this one was already executed before, so we saw still have the cache, but this one is new. Okay, so here after the clean missing data we have here preview the data, clean dataset. Yeah, so 9,000 after clean. And how about this one? 6,000. Okay, in the clean missing data, just make sure that this is the remove the row. Remove entire row. Yeah. But here in the select column, we already exclude. Yeah. Exclude the two column. Okay, just to make sure that the column is different. Go back to the jobs. Clean missing data. Preview. Okay, so the column is 22. This should be 2 less, yeah, here. Yeah, only 20 because we removed 2 columns. Okay, so in the process of the training, the second model, okay, now is assigning the data to cluster for the second model. After that, we evaluate, compare. So looking at the data, the right side is 3000 more data assigned. The left side was 6000, about 6000. This one is about 9000. So let's see whether the data is happening. Yeah, so right click preview the data. Okay, yeah. So this is the for the cluster number 0, 1, 2, and then this one is on the left with all the columns, and then this one is with 2 columns are excluded. Yeah. So average distance to the center overall average is the 2.8. Yeah, this one is 2.9. So slightly longer the distance. Yeah. Maybe because more data, then more spread the data, not in the middle. So this average distance to the cluster center is slightly higher. So 2.4 and this is 2.6. Okay, so the impact of having more data, but the data is more varies. Yeah, so spread it in the wider, or the range is become wider, then the cluster distance is slightly, average is slightly higher, but it's okay. Yeah. Other model maybe showing you different metric like silhouette score. Yeah. And then that one is not shown here by default. Yeah. In Azure they use the distance to the cluster center. Yeah. Okay, so from this then we understand that the first model, which about 6000 data, the distance is shorter. Yeah. Okay, but again, as I mentioned earlier, that this not I mean because the data is different. Yeah, so we don't really compare apple to apple. Okay, and yep, so that's the interpretation of this clustering experiment. So the machine learning model that created able to group your data that previously unknown, which method is needed or used to group the data into the different groups cluster. We can automate the machine learning to help us to allocate this each individual data into the cluster by maintaining the distance, minimum distance to the center of the cluster. Okay, yeah, so that's the interpretation of this data. If you want to play again, yeah, you can try to change this. Okay, so do we have any other clustering? Yeah. So for example, we have the k-means clustering, then after that yeah, so we don't have much clustering, yeah, k-means clustering only. Okay, so yeah, okay, yeah, so I think that's all, yeah. So just collect the screenshot as needed, then after that you can discuss the, okay, by the way, let's see the just now the assigned data to cluster. Yeah, you can also see how this 2922 rows are assigned to the cluster 0, 1, yeah, this one based on the minimum distance from the centroid, yeah, from the center of the cluster. Okay, so collect the screenshot as needed, then you can close this lab.